All right. Welcome everyone to this month's community meeting. Last one was 4th of July, so this covers 2 months of stuff, and we have some really exciting updates. So let's go ahead and jump forward. So here's the agenda, and let's go ahead and jump on in. Of course, we have to remind everybody, we actually, these are our community events. So Mondays at 9 a.m. Pacific, usually, we have either the community meeting on the first Mondays, which is like kind of recorded and has an explicit agenda. And the other Mondays is sort of the developer hour, which is more about technical conversation and is more of a free-form discussion. We've also added, Ramiro has volunteered to every Thursday host some office hours to help people who are implementing ops and working on that sort of thing. So feel free to join that. And then we have our Discord, which is probably the best place to start if you have any questions. And then we have Discourse for somewhat longer discussions. Discourse is like an online forum. All right, so this slide is almost too small to see actually, but we've actually, wow, that really is almost too small to see. Anyway, bottom line, we have a lot of contributors, and you can tell by the font size. And so I'll go ahead and just read them off just because this font is so small. So here is Nod, and then Cerebrus, and then Google, Microsoft, Alibaba, ARM, others that I couldn't categorize, ByteDance, Intel, Cruise AI, and D-Matrix. So that's quite a lot of contributors, and I'm really happy to see the community growing and people reviewing each other's code and everything. It feels really healthy to me, and a lot of these represent real major features that folks are contributing, and I'm glad that we can be this kind of watering hole for everybody to work in. So let's jump right on into the agenda. So Ramiro, do you want to kick us off on the ops?
Yeah, so this is a list of ops that have been added since around 2 months ago, the previous developer meeting that we had. And these are all ops that have end-to-end support with a ref backend. So that includes the Torch to Linalg and Torch to TOSA paths. And so this is just to show, that there's been very active development in Torch-MLIR. Especially many of these ops require very creative or very inventive lowerings. So thank you everyone who has been working on all of these. They have unlocked many different workloads that we're interested in. Yeah. Next slide.
All right.
And so I think, every week or so I see a new name in the Torch-MLIR repo, and so that's really nice. We're growing quite fast. And so to help the newcomers and even current contributors, I host an office hours every Thursday from 8:30 to 9:30 a.m. Pacific time. And that's subject to change if it doesn't work for many people. But the purpose of the office hours is to sort of complement the current developer hour that we have. And it's meant to answer slightly lower level or entry level questions, such as I added this lowering, but now my program crashed when I run the end-to-end tests. How can I debug it? Or what approach should I take to add this new PyTorch shop into Torch-MLIR? Or any sort of questions regarding basic understanding of compilers or MLIR. You can come and I'll hopefully answer those questions. So yeah, it's open to anyone, and it's not recorded. And yeah, feel free to join.
Thanks, Ramiro. Yeah, that's going to really help speed up a lot of the work and help people get onboarded. So these, like any recurring meetings that we have, are posted in some form in our discourse forum. So if you ever need to check out what's going on there, we just go to the discourse forum, which, by the way, all of that stuff is linked from our README as well in our communication channels. All right, Anush, do you want to kick off the new workloads?
Yeah, so the past couple of months, we've been kind of like shoring up some of the Torchbench models that we've been targeting. And I think that's more or less done. We have 25 models out of Torch in Torchbench that should work with Torch-MLIR. We tested downstream in Shark, and Shark is just Torch-MLIR plus EV plus nodes integration and tuning. So we do have some more workloads that are kind of that require some modifications to the source, and we do those modifications out of tree, just like how Hugging Face has modified GPT-3 and all that. We modified that. Mostly it's to remove tentacles of like Megatron or device-specific stuff and make it cleanly lowerable into Torch-MLIR. So we are working beyond the Torchbench models. We do have 3 models that are high priority for us. DLRM, at least with dense mode, we have it validated for certain cases. We're validating a few more options, and then eventually, hopefully, DLRM sparse will open up, like when we're ready for discussion with like sparse support with different kind of sparse. We can use that, but DLRM is an okay shape. V-diffusion is it's just like DALL-E text to image generation, and it uses OpenAI clip inside clip width, so it's conv plus attention model. That one also we have validated with numerical accuracy down to on the CPU, GPU, CUDA, and Vulkan. And you can find all of that in the Shark repository. We do have some other models that we are working on, and these are all the public models. And as we go through and wrap these up, we'll continue adding more. So if you have any new models, any problems you have, please do reach out on Discord. We're happy to help and point you to examples, especially like unrolling loops and things like that. All the nuances of what you see in GPT-3 or in V-diffusion. I think we've probably hit, and we want to hit some of these models some more. But if others have interesting models that we should try to chip away at, please do bring them up. I think we'll slowly transition to having complex model support from obviously the ops, corresponding ops too, but then now how these ops are stitched together and having numerical consistency is going to be kind of the key thing going forward. But yeah, that's where we are. Any thoughts, questions on workloads or models that we're running? And we're running all of this nightly. So if you look at the GitHub actions in Shark, you'll see it runs, it lowers through Torch-MLIR with the latest Torch-MLIR and runs on CPU, GPU, CPU, CUDA, and I have a pull request to enable AMD GPUs Me100 also in the CI, and then we are gonna and we have Mac Studio also in there, but we'll enable essentially all these workloads, and all the hardware will be like a nightly run. So that's where we are.
Awesome. Thanks, Anush. And thanks for, a lot. I have to recognize that a lot of these models, the ones outside Torchbench, do require some amount of wrangling to get working. And I it's awesome that you're doing that work, and also, hosting that in open source for everybody to, take a look at and benefit from. So thanks a lot, Anush, for doing that. All right. So the folks at Microsoft have been, touching on a number of topics related to our LLVM Integrate workflow. So I wanted, they volunteered to talk about their Integrate workflow and kind of help to host a discussion on what we want for Torch-MLIR as an integrate workflow. So do we have, I see Stella, I see both Stellas actually, and Shay, I see you there.
Yeah, I guess I can start, and there are certain things that I would probably have to defer to Stella Staminova. So yeah, hello everyone, my name is Ashay. Stella and I are from Microsoft, and given the recent changes in some of the Torch-MLIR dependencies, we've been running into some pain points that some others on this call likely face as well. So my goal is to try and see to the discussion, maybe brainstorm some ideas, and possibly get some feedback on how we can collectively reduce this shared pain. So our compiler at Microsoft depends on both Onyx-MLIR and Torch-MLIR, and both these projects have, among other things, either a direct dependency on LLVM and also an indirect dependency on LLVM through MHLO. And so the consequence of this dependence tree is that updating LLVM is starting to get rather time consuming, since it requires aligning commits and patches across various projects. Sean, could you go to the next slide, please?
Mm-hmm.
Yeah, so here's what I mean by this LLVM tag update process being time consuming. So every week, we first have to find a quote-unquote known good commit of LLVM. And the reason I say known good is because for us, that commit has to work across Clang, MLIR, LLD on both Linux and Windows, with and without shared libraries, etc. And if, of course, the most recent LLVM commit isn't such a known good commit, then of course we have to go fix it upstream or locally before we can proceed. Then in step 2, MHLO, as I understand, may not build with the most recent LLVM commit because of shared library build issues. So we may have to fix some CMake files in this step. In steps 3 and 4, we need to update Torch-MLIR to match the LLVM and the MHLO commit. Now, luckily, on the Torch-MLIR side, we've been grateful that we haven't had to make a whole lot of changes when updating LLVM, but that's not necessarily the case on the Onyx-MLIR side. And then we have to repeat this process next week. And so this process is not only a big time sink, but it is, if you look at it more broadly, it's also redundant. Like, I imagine that there are folks on this call who also have to do something very similar at their end as well. So collectively, we're probably spending many hours, sometimes if not days, doing this kind of redundant work. So as a step to alleviate this kind of shared burden, we wanted to propose a possible solution and get some feedback. Sean, next slide, please. Yeah, so, oh, by the way, the credit for this slide goes entirely to Stella Staminova. I'm just summarizing her points here. And this also has elements of the 2-tier hierarchy that Stella Lorenzo suggested in the discourse discussion linked below. So the broad proposal is that once a week, we as a community mark a specific LLVM commit as quote-unquote green, if it can build the core LLVM projects like MLR, Clang, and LLD with some specific configurations. And that downstream projects like Torch-MLIR and Onyx-MLIR target the specific green commit for that week. So if we are doing a Torch-MLIR update this week, then whatever is the most recent green commit, we pick that. And the rationale behind suggesting this approach is that it is, of course, way faster to update just Torch-MLIR or just Onyx-MLIR instead of everything at once, including our internal code base as well. Also, sometimes these updates are indeed difficult, and I've personally had this experience that sometimes I don't have the full context of the update, and so reaching out and or in some sense making the work public, this update work public, we can share the effort, signal when updates will be complete, and possibly ask for help as well. There's also a discourse discussion started by some folks from ByteDance AML team, and thanks to Sean for looping us into the discussion. So this is clearly a problem for others as well, and so we would like to hear some thoughts on whether this proposed solution might work, or if you would prefer something else.
I have a question if nobody else has anything.
Sure, go ahead.
Actually, so on the Onyx-MLIR side, I haven't built Onyx MLIR and tried it, but do either of you or Stella work actively on that project? Like, how much do we have the Onyx MLIR folks also involved in this process?
So Stella, do you want to comment on that?
So Onyx MLIR has a dependency on LLVM that they update about monthly usually, and the updates are often non-trivial because they're tightly coupled with MLIR, and as MLIR updates features somewhat rapidly sometimes, that can cause a lot of complications.
Okay, so what I'm trying to understand is, if we do something like this, is the proposal we have a clearinghouse of like incubator projects or downstream LLVM projects that we all have a shared like CI thing, that every new LLVM commit we're trying to keep Torch-MLIR, Onyx MLIR, and anyone else that we choose to bring up into this MHLO, for example, right? So let's say these three, we just continually keep them up to date with the latest LLVM commits. And so then we try to also give a FYI signal for things into LLVM commits to say, hey, this is probably this commit's going to break downstream, even if it doesn't block it. Is that roughly what we're thinking of?
So I don't know if you've had a chance to look at the discourse discussion. There's a lot more details there of things that people are talking about, whether they're feasible or not. In an ideal world, I think one thing that would work well is if we agreed on a commit at a specific interval that is a green commit, and then anyone who wants to update can pick that commit. So let's say Torch-MLIR wants to update weekly, they can update weekly to this green commit. So then there will be a corresponding version of Torch-MLIR to that green LLVM commit 4 times this month. Now, Onyx MLIR only wants to do it once, but they will also pick one of those 4 commits. So at any one point, Onyx MLIR and Torch-MLIR will both correspond to one of a subset of commits. Right now, one of the issues, and this was raised in Onyx MLIR, is that as Onyx MLIR changes LLVM commits based on some decision they make, and Torch-MLIR makes a different decision, projects like ours, but not only ours, they try to use both, can never pick from both Torch-MLIR and Onyx MLIR something that matches. And then, of course, they both have a dependency on MHLO, and then they pick different commits there, and it's suboptimal. I saw Stella had a question also.
Stella, you're muted, or somehow your audio is not coming through.
Sorry, can you hear me?
Yeah.
Okay. Yeah, a couple of comments. One is that this thread is being watched by a lot of people. I know that senior leadership on the Google side is also reading this thread and acknowledging that we also have this problem layered in depth. So I do think that this is that there's probably a what we decide to do right now aspect of this that relieves the burden, and then there's also a when the cavalry arrives kind of, and an actual resourced solution to some of this that might emerge over time. That's just my guess. So the concrete question was, is it sufficient for right now to do what you said? We just kind of opportunistically have one commit in common a month, and then can we just pick that commit based on the highest frequency changer? One of the things that we've done, just in the absence of a better solution on this, is just kind of pick the person in the room that's doing the highest frequency updates and make sure that the next one picks that and the next one picks that. And so in this situation, like leaving aside where the ultimate green comes from, if Torch-MLIR picked a commit first, could Onyx MLIR pick that same commit, or is there some additional coordination as to whether that commit is good enough?
So I think Ashay made a quick reference to this, but that would work assuming that the commit that was picked satisfies the requirements for all of the projects, which they don't always. So Torch-MLIR doesn't care, for example, about shared libraries. This is just an example we're using because we ran into it recently, but Onyx-MLIR does. So I pushed an Onyx-MLIR update based on a commit from Torch-MLIR, and the shared libraries didn't work.
Right.
So we actually have to do some extra work to pick a commit that satisfies both requirements. And this is just one requirement, right? Our project requires LLD and Clang. So if we picked a green commit for MLIR, Clang might not work. And this has happened. So in theory, if we pick a commit that satisfies all of the requirements and the most frequent updater was kind enough to pick something like that for everybody else, then it would be fine. But we have to define what green means. Also, I think for MHLO, most of the time, the update is just a commit update. There don't appear, from what I've looked in the history, a lot of changes directly to the code oftentimes. So I think that update happens a lot more frequently than all of the other projects and a lot more cheaply than all of the other projects. So maybe most frequent updater isn't necessarily the best choice, but something more sophisticated, like if Torch-MLIR updated once a week to a commit that met everything that also was in MHLO, that could work.
Right. So MHLO, we're also floating a plan that is not agreed to yet, but that is going to make it much cheaper to vendor as well. You know, because it has been observed MHLO was built and can be made to build more to kind of be light on the MLIR infra, you know, so that we can, you know, do shallow vendoring activities on it. So yeah, that might not be the best source of a green commit, although, you know, I can tell you that commit does has had significant, probably exhaustive Clang tests done on it and LLD tests just by virtue of how it gets picked. Just thinking out loud here a little bit. Maddie, why don't you take over?
Yes. So on the MHLO topic, we actually integrate internally much more frequently than what is pushed publicly. So if there was a need, we could also push branches into the MLIR HLO repo with like almost every single individual commit from LLVM with the fix for MHLO. Those will not go through the same amount of testing that Stella mentioned. But that's a possibility in case, like, just to avoid that there would be a gap in between that will not catch the green commit you mentioned or you want. And the other thing is, yes, Google is testing heavily. So any commit that you see it from LLVM used in TensorFlow, for example, has gone through like testing all of Google almost. There is a caveat to it in that it only builds, you know, mostly x86 Linux. It won't test ARM, ARM64, or even more exotic platform or Windows or Mac necessarily. So there's no guarantee on those. And for vendoring MHLO, it's definitely possible, but you may still, like, there will still going to be breakages by the fact that MLIR will change. And so this vendor copy of MHLO will need some maintenance, probably minor, but still.
Yeah, we've done that on the Erie side, where we've got long-term forks of all of the projects that we depend on that we will carry patches on, and usually even in the kind of large-scale breakage eras of MLIR, MHLO patching was not terrible. I mean, none of the stuff is great. It's not something you want to do over and over again. But I think that if we can, you know, aim to something that's reducing, you know, the job needs to be done. Let's not do the job 3 times at each layer. You know, it's that's kind of what we're aiming for. My other point was that considering Erie, which we haven't put on the slide, but is also would like to consume some of the stuff in some fashion. You know, we often find that we've got to patch LLVM, you know, because it doesn't patch, or it doesn't meet our, you know, what it was tested at whatever green doesn't actually fall through. And we've had problems in that on RISC-V backends and bare metal and stuff that no one tests basically. And so we've long since had to maintain that we pick an LLVM commit, and then we also carry local patches for everything, and we've got a repo for that. That's suboptimal. Like you only want to do that in ultimate leaf projects, but I'm not sure it's actually avoidable either.
Yeah, we have a similar issue because we build on platforms that are not so popular or that are private to us, and we end up having to carry our own patches as well. I think a lot of this is being duplicated across such a large variety of products. I think any improvement overall will save a lot of time. It might not save a lot of time for any particular project, but overall, I think it would.
All right, folks. So we've already spent 15 minutes on this topic, and I think it's become clear that this is like, bumping up the, the hierarchy. And so I think maybe I'm going to take an action item and suggest we do an ODM, an MLIR ODM, to sort of increase the scope of this discussion, which it sounds like is needed. And then ultimately, maybe we can, hopefully the result of that, we can take to like the whole LLVM community. Yeah, it sounds like there's definitely a lot of work to do here, but it's going outside the scope of this meeting.
Is there, can I just ask
Sure.
one more question before we move on? Is there any kind of experimental action item that we can do and try for a month? Because this is basically a continuing grind. We can try anything for a brief period of time and see if it helps. Is that something that would be of interest?
So one thing that I would quickly suggest is our team picks a commit that's green to us, and we often do the Torch-MLIR update to LLVM as well, not always. So maybe we can try tagging that commit somewhere and then updating Torch-MLIR to it, and then hope that other people can pick it up. We do testing on several different platforms, so we're relatively confident in the greenness of our commit. But I'm not sure if it would meet everybody's requirements.
We're all talking about shades of green at this point. So.
I think that's a good idea. Essentially, in effect, since Ashay's proposed updating it, the commit that Ashay picks will be a green commit for you. So implicitly, Onyx MLIR would work, and we'd just magically have, we're bumping Torch-MLIR, but we're relying on your CI downstream because you have visibility to both Torch-MLIR CI and your CI. Eventually, your CI will have to bubble up if we want it to be a community effort so that others can share that. But until that happens, having it at the in your thing makes sense. And if someone is blocked, then we'll raise an issue and ask you, could we update to this because we need this or something like that, and then we can figure out how we can roll that in.
I mean, I think in what Stella's describing, the train can always move forward. We just want to make sure that it crosses certain struts in the track. So
exactly,
as long as if the experiment is that occasionally you guys have a commit that's deeply important to you, and you publish that, and we see if that's a good rallying point, and you kind of move the projects forward to that. I don't think that imposes a coordination overhead at this point.
Stella, I think the implicit coordination is that in the past we've agreed that Ashay is doing a weekly update to LLVM. We just didn't agree what that point is going to be. But
Gotcha.
Based on what Stella is saying now, what we're saying is, yeah, it'll be something that you guys know is good. Outside, we don't know, but it's forward progress. So we're saying, okay, as long as it's forward progress, we'll take it.
It could be two things. It could either be we don't care, update to whatever because we don't have a new green, or hey, we've got a green that's in the future. Can you pick this one, right? Based on what I'm hearing.
So Ashay does the updating to Torch-MLIR sometimes, and my suggestion is whenever he does it, he'll pick our green commit. So we've tested it, we validated it, we know it will work with Onyx MLIR.
Great.
The one thing we don't know right now is whether it will work with MHLO because we haven't started doing that testing yet. So I'm hoping that MHLO just magically has a matching commit.
I mean, we're going to need to run the experiment. MHLO has much less surface area to break, so give it a shot. We also maintain. Or we can probably even maintain some branches in the MHLO repo if we needed to run this experiment a little bit better in the short term, because if you had to do local patches to it or something.
I think that's a really good idea. What Mehdi said in Stella, like if there are local MHLO top of tree LLVM things that's like hey, it compiles, but we don't know what state it is, it probably will help Stella and Ashay in case they're picking something that's a little further downstream, because it's only Torch-MLIR and Onyx-MLIR eventually that we're updating. So if our CIs have to catch it, we have to catch whatever test it is, right? So even having that outside, I think, will be another, like, step 2 of the experiment. Step 1 is Ashay and Stella do the update to whatever forward green there is. And step 2 is if MHLO latest to LLVM is available in some like latest branch, then if they have to pick a patch, they're not like, guessing and re-implementing it. They just pick whatever's there.
Yeah. Okay. So we can move on now. Let's try that experiment. Let's all coordinate on an issue somewhere. Feel free to tag us all in, and let's try to check back in. I'm somewhat less confident that a broad MLIR, LLVM, ODM that's not domain specific is going to converge on a great solution on this, but it can probably it can probably produce more drive for project infrastructure and other things that will help. So let's make sure to check back in on this and kind of keep running an experiment.
So Stella, just so I hear you right, so the idea is we're gonna run this experiment, and then in like about a month, we'll kind of maybe present to the LLVM, to the MLIR committee at an ODM, be like, hey, we found this, and what do folks think?
That'd be my suggestion. I wouldn't walk into a broad, non-domain specific
abstract
discussion with the LLVM community. I'd come in with this works. We need this kind of investment. Let's talk about this kind of thing.
Awesome. Okay, so Ashay and Stella Stemanova, if you could just, I don't know where you're going to post this, but maybe like a GitHub issue, just keep us up to date on this work stream, just so that we know what's happening. And yeah, just so we can all follow along and keep the paper trail.
Sounds good.
All right. Okay. So I'm going to leave this a little bit later because I really want to get to the Torch to MHLO support, which is one of the major features. And Zihong, are you going to present this?
Yes, I can present. Yeah. So let's get started. So what is MHLO? So MHLO is a carefully fixed selected list of operations using MLIR with extensions for dynamic shape support. And why we want to bring it to Torch-MLIR? The first reason is that by bridging Torch dialects with MHLO dialects, we can reuse existing optimizations and facilities in the MHLO ecosystem. And the second reason is that since MHLO supports TF model by nature, so this would also enable user to convert and lower like different front-end models like PyTorch and TensorFlow, etc., into the unified MHLO MHLO, so which can reduce engineering effort and ease the subsequent backend work. Okay, let's go to the next slide. And here is the current status. So we have already raised the RFC in the GitHub issues, and we have the CMake build and the code structure merged, and also the Torch to MHLO lowering pipeline ready and merged. And now we are in a stage that to contribute the operator conversions. Like for example, we have the basic ops merged, like around 35 ops, and also view-like ops and slice-like ops, and also the gather ops. And here there are many items like in the plan. Maybe it would be like ready in this month. So we will have like more ops ready and get merged. And also we want the configurable decomposition. So this is because for different backend, targeting backend, we might want to we might want to have like a different decomposition rules. For example, for some dialects, we might don't want to like decompose like a layer norm, something like that. So we want to make the decomposition in the Torch dialect to be configurable. So this is one thing we want to do in this month, and also we want to have like several examples to show how to lower from the Torch to MHLO, like for ResNet 18 and TinyBird. And there are also several items which is good to have and have wanted. For example, we want to show like how does they support dynamic shape and how to support training. Yeah, basically these 2 items. Yeah, let's go to the next slide. And you can find more details like in RFC. And the contributors includes like the developers from the ByteDance applied machine learning and also the Alibaba Blade Disk developer team. And last but not the least, we welcome everyone interested to be a part of this effort. Yeah.
Thanks,
Yeah,
Zihong. I think that's the last slide. Yep. Yeah. So this is super exciting, and it's kind of one of the. Paul, can everybody see the slides?
Yes.
Okay. Paul, this must be an issue on your side. I'm sorry. Yeah, this is really exciting. This is one of the kind of edges in the MLIR dialect connectivity graph, which I think is what has been missing for a while, and I'm really excited that that you folks have stepped up to implement this. So that's awesome. Thank you so much. Let's go back here. So I just wanted to do a quick health checkup on our CI. So we've been making some changes to the CI recently, and I think I'm just curious, and also, the community has been growing and everything. And so I just wanted to ask a few questions and just let people speak up and see, is there anything affecting people's workflow that, we could improve for in terms of project infrastructure or project culture or anything like that? All right, well, I'll take it that we're healthy then. Awesome. Yeah, so I created a GitHub issue if you want to drop any feedback afterward, or if you're watching this on the recording. So feel free to drop any feedback in there. I'm really glad to hear that all the CI and everything is working well for everybody, and people aren't getting blocked up on reviews. Anush, did you want to talk about the CI plan?
Just a quick update on what we've been doing for the CI. Over the past month, we've been trying to get as much of what we need coverage into the CI. Before, the release builds and the CI were kind of like hodgepodge. Now we have a matrix build. So you should get a signal in a fully cached environment, like 5 to 10 minutes. That's what we'd like you to have. So if you put up a patch, the first build should give you in 5-10 minutes whether it's good to go or not, and then get a coffee and come back, and in an hour you should get, if that's green, then everything should ideally work. But obviously complex cases like what LTC and MHLO has been less about it, but LTC has dependencies in PyTorch, so those you may hit corner cases with each of those other variants. And we still have to add a cross-compile one here. But other than that, we're working on some other things to reduce there are 2 source builds that have like 25-30% cache hit that also we want to try and reduce. But overall, we're aiming for like 10 minutes. If you can get the first signal, within an hour, get all the CI through that. And then the CI should cover everything that the release build would be doing. Right now, there's still a little gap with setup.py not being there. There's a lot of work that's going on behind with the PyTorch integration that we want to reduce and not have to build all of the op surface, etc., that we don't use. So that will continue to evolve and make progress over the next few weeks, months. But happy to answer any questions on the CI. And in general, the strategy that we have on the LLVM side, we are a little more gated, right? And we go to a good known commit. On the PyTorch side, we're drinking from the fire hose. We want to, so we're kind of trading speed for stability. So you could have a CI that fails while it passed in the last time, and the onus is on us to make sure that PyTorch hasn't changed last night. It would show up in the nightly anyway. So it's just that now it'll show up, as soon as it breaks. So the idea is that we're going to try and do that as much as we can before we start taking on something like what we're doing on the LLVM side, which is a submodule, and build to that, and then pay the cost to update that. So until we can handle it, we'll do it. When we come to a point where we cannot, then we'll trade in and we'll do the same thing and add one more gated submodule update, which will be for PyTorch. Suraj, Sean.
Yeah, Suraj, why don't you go first?
All right, so I'm really speaking on the behalf of my colleague Roman, who's based in Cambridge, and it's a little inconvenient to the day for him. But one of the CI targets we're interested in is Linux, Ubuntu on ARC64, and we're doing this by running a virtual machine on the M1 Mac. Seems to work well, but there are a few sharp edges as to the version of the lab Torch and Torch in general, and how to make that work properly. And he's made a lot of progress on that. We would ultimately like to be able to have this target as one of the bulk targets available over here. And I just wanted to check that it wouldn't be a problem for us to contribute this when it's ready to go. Would that be okay?
I think that'll be great. Just to confirm, this is an ARM64 compilation, right? That's what you would want to do. Yeah, no, definitely. I think there's one issue that we're waiting on that Jacques and I think Maurice is also here. They're looking at where we're cross-compiling Torch-MLIR is broken or not. It has, you have to do it in 2 steps, and you'll have to build like 3,000 additional files that causes the cross-compile to not be efficient. So as soon as that issue is fixed, I'll add an M1 cross-compiler and AR64 cross-compiler also to the CI. But yeah, I'm happy it's working for them. If they have any contributions to it, more than happy to let them do it too, by all means.
I should also mention that it's not just ARM64 but not Darwin. It's Linux on ARM64 by using virtual machine. So that's kind of different from what normally people would do.
For sure, but from our perspective, the fact that it's a virtual machine doesn't really matter. The fact is that it is an ARM64 native or an ARM64 cross-compile, and we can add an ARM64 native and an ARM64 cross-compile, and separately an M1 cross-compile to the mix. Right now we have an x86, and all of them will all be parallel and fit within the 1 hour SLA that we have. So it doesn't really matter in terms of that, as long as helps broaden the community. I think it's a good thing to have.
Thank you.
Sean, I think you had.
I think Marius might have a more important thing.
Regarding the cross-compiler issue, that's actually an MLIR issue, it seems. There is a patch which I just recently approved, which should fix also cross-compiling for Flang, which relies on MLIR, of course. And I think we have a similar issue in Torch-MLIR, and hopefully that's going to be fixed. Yeah, maybe by end of next week. Let's not be too optimistic, but I'm working on that actually.
Thank you. Yeah, once that lands, we'll be in really good shape on the CI front. And once that lands in MLIR and we pull it in with an LLVM update, then we'll update our release builds to start picking up to do the cross compile. Because right now our release builds have like some quirks where we just luck out with the macOS build, and it builds for macOS host and ARM. And we want to keep that alive. So as soon as this lands, then we'll switch the release builds, and then it'll be a little better.
And Anush, what is this cadence of the PyTorch like bump? Like, is that like a commit that we have stored in our repo right now, or like how do we pick that, or what uses that?
We're still we still have like developers are still on the what we have had for months, right? Which is you have the PyTorch local install thing. But in the CI, we capture top of tree. We build from the SHA so we can catch anything that would have broken like in the next nightly when the PyTorch bumps.
Yeah. So just to be clear, so I think there seems to be a contradiction between kind of using like the latest top of tree, and which I assume updates every few minutes for PyTorch, and this caching. So like, do we throttle that so it's like not literally the most recent PyTorch commit, but maybe like every hour or something?
I don't think. The caching, because you see the cache getting invalidated.
I mean, I'm just curious. So it's like, are we really just pulling on every single CI run, like the latest Torch-MLIR commit?
For not all of them. For the source builds, yes. The source builds. Yeah, just
okay.
The source. Yeah.
All right. Okay. Wow, that's pretty aggressive, but yeah, I guess. All right, let's see how that works.
Let's see until it slows down, right? And then we'll, because now if you commit a fix upstream, you can Torch-MLIR, like we're paired to PyTorch closely until a point where we say we it's all running on Azure now, so it's there's no my local SSD. I actually do have for Shark. I do have like an SSD that I run just so that my Mac doesn't burn out. Swap the SSD because it's burnt in. it's soldered in. So I do have like 2 or 3 NVMe drives sitting around that run the nightly build for Shark. It is directly on PyTorch. So we do get exposed to things like they made a breaking change that they coordinated with the PyTorch XLA guys. We were not involved in that, but I think Henry saw that, and I think Vivek fixed a patch about it. But we will find that out as soon as it lands, and which I think is the right thing, and we need to be able to handle that anyway. It's just that typically we would have had to handle it tomorrow morning, but right now it's like, okay, it landed and this is what it is. So we'll have to fix it anyway.
Awesome. I believe that was our last topic. Let me see. Yep. So we have 8 minutes left. Do we want to continue any of the previous discussions? Going once? Going twice? All right. Well, let's get 8 minutes back. And thanks everybody for joining. It's been very exciting. And yeah, next first Monday of the month, that would be September 5th, is a US holiday. So I think we'll be skipping that day. And so that means that our next community meeting will be in 2 months from now. Just a heads up. All right. Thanks everybody for joining. Bye.